The RC Plane of Death.
Our names are
Mateo,
Nelson, and James, and today we will be talking about our project, the RC Plane of Death. The objective of this project was to build an RC plane for land mapping and surveillance. Land mapping with drones and RC planes can be fuel efficient and more efficient in general. For example, you wouldn't have to walk around for hours.
Today we will be talking about how we make our plane and some of the science behind it, like thrust, drag, and lift, and weight. We will also be talking about what we can do differently next time and how the plane failed.
The plane we made was a propeller plane. It had a single propeller on the front, used servo motors to turn and go up and down, and had a body made out of foam board. Turbo motors are small motors that turn 180 degrees. To turn the plane, we used a flap called a rudder, which was located at the tail of the plane. The rudder is a vertical flap. We didn't have any wing flaps because we didn't think we would need any and to save money. To make the plane go up and down, planes use horizontal flap or flaps called elevators, which we only had one of. The elevator is also located at the back of the plane, right underneath the rudder. The electronics in the plane were pretty simple. The main motor, the one at the front that spins very fast and had the propeller, was connected to the speed controller, which is pretty much the brain of the motor, which was connected to the battery and the receiver, which receives the commands from the controller and tells the motor and the speed controller what to do. The receiver was also connected to the two servo motors to control the flaps. Thrust is a mechanical force. A mechanical force is a force that involves direct interaction between two things and results in a change in the configuration of the thing. Thrust is a force that moves the aircraft in the direction of the motion. It is created with a propeller, jet engine, or rocket by pulling in then pushing out air in the opposite direction. One example is found. Drag is the force that acts opposite to the direction of motion. Drag is the force that slows things down by moving through gases and liquids. When a moving object pushes the liquid or gas out of its way, the gas or liquid pushes back on the object, slowing it down. This drag force is always opposite of the object motion, and unlike friction between solid surfaces, the drag force increases as the object moves faster.
Wings are made so that air goes faster above the wings than below. The faster the air moves on the top, the less pressure that's on the wing. And then the bottom is basically moving at normal speed, or faster. And that's adding pressure. The slower the wind goes, the more pressure it adds. An example of lift is if you've ever put your hand outside of a car window and then it gets caught on the wind and it gets carried up or down. That's an example of lift. To have good lift, you need to have the center of mass just behind the tips of the wings, and then you need to have where the wings start just in front of the center of mass, or the plane will die.
in a plane, the weight is the opposite force of lift. While lift is always pushing up, the weight is always pulling down. So for a plane to fly, it needs to have more lift and thrust than weight, or else it wouldn't get off the ground.
The results. We have only flown our plane twice, and it crashed both times. Our first flight was very brief and disappointing. Our plane went straight up, then straight down, and crashed on its tail. We quickly rebuilt it and made adjustments and got everything working again. The next day, we decided to test it again. We gracefully threw it forward, and it flew for about 5 seconds before crashing headfirst into the ground. As soon as it crashed, we saw smoke coming from the inside of the plane. We picked it up and removed the engine and looked inside our plane's fuselage.
Something had happened and the speed controller had caught fire.
January 20th at 10:33 a.m., we had lost all hope for our plane.
We learned lots of valuable information from watching our plane crash. The first thing we learned was that it's very important that all of the internal components like the battery or speed controller are secured and fastened inside of the plane to stop them from moving around the fuselage. Another thing we learned is that it's very important to make sure that everything is working and is working to the best of its ability before you test it.
Next time, we can make it so the speed controller needs to take less power and has fewer components asking for commands. We could also try to add ventilation, and we could add a different power source for the receiver so there's less stress on the battery.
Although most projects end up going well, sometimes they don't. These are the kinds of projects that can show us how to be better and what we can do next time.
Thank you for watching.